right? So so let me figure out how to use the presentation here because I prepared something and here's the PowerPoint. I hope you can see it. Any hands if you can see it, if it is visible to you.
Yes, we can say it. But
All
maybe
right, so
if maybe
let's
we just put it in presentation mode,
in presentation mode, right? All right.
the slideshow.
Okay, cool. So mobile engineering, that's the title, unleashing the power of mobile technology. After all, it's the closest device that we have in our hands today. You can't go anywhere without your mobile device that uses Android or iOS. I understand some people still use uh, the smaller versions that use keypads that don't support Android or iOS. We're not talking about those. We're talking about Android and iOS devices. Maybe we slightly go through Microsoft, the software that is now basically extinct because times go. So the objectives of this presentation are just simple three things, but we expand as we go. First of all, we talk about the definition of mobile engineering, the mobile engineering process, which is just basically an overview, and we can go in detail when we reach those slides, and we talk about the development process. So mobile engineering refers to the field of software development and hardware optimization focused on creating applications and systems for mobile devices. It encompasses a wide range of technologies and disciplines, including mobile app development, mobile web development, mobile operating systems, and mobile user experience design. So, as the first paragraph says, mobile engineering is the field of computer science uh, or software development, basically software engineering that mainly
Oh,
focuses on mobile
sorry,
devices. Huh,
we're
yeah,
still we're still seeing the first slide. I'm
you're
not.
still seeing the first slide,
Yes.
not the
Can,
second slide.
can you reshare your screen to the other to the yeah? Now we're seeing the third one.
Okay, so we should just use this.
Or you can just reshare your screen to the other screen that came. I think you're just sharing a particular screen right now.
You're sharing a previous screen.
Yeah.
So
But
is
of
this
course, you can
moving? It's
just use
moving,
this.
right?
Fine. Yeah, that one is moving.
Okay, we should just use this one then.
Yes.
It's fine, right?
Yes.
Okay, so as I was saying, mobile engineering refers to the field of computer science, software development, and hardware optimization, right? That basically means that we're developing apps that we use that are developed using different technologies. For example, we can use the technology for developing websites. We can use the native technology for developing mobile applications. And to do that, we need some expertise in mobile user experience or UX design, or as they call it these days, UI UX, right? So the evolution of mobile devices have came a long way since inception, evolving from basic feature phones that I talked about previously, the Nokia's, the little small Nokia phones, to these powerful tablets, which are just basically powerful computers in the palm of our hands or in our pockets. The introduction of mobile apps in the app stores revolutionized the way we interact with technology, enabling a wide array of functionalities and services at our fingertips. The Google Play stores, the Microsoft Store, in the Apple Store, those things commercialized the app development and gave it value so that us as engineers can work extra hard to get our products to work so that people can download those things, and after they download them, they give us revenue back through the Google ads and stuff. Mobile app development is crucial in the aspect of mobile engineering involving a creation of applications specifically designed to run on a specific platform. After all, you can be an engineer that develops mobile apps for both Apple and Android phones. These days is possible with frameworks like Flutter, frameworks like React Native. They allow you to write code that can work on both devices after you compile it on those specific devices using one code base. As we proceed through the slides, we see we talk about the cons and advantages of using those types of development methods or strategies. And as a software engineer or as a mobile engineer, you have to be selective of the platform that you develop on, because if you use a tool that is supposed to attack all those platforms at hand, for example, you're using Flutter, you want to develop an app that will work both on Apple and on Android. That app is instead of being a small code base as it is promised by those frameworks, it becomes a mess, and you have to use conditional statements and stuff so that the widgets or what the buttons can appear differently in different platforms, which makes it so sophisticated when developing an app. So developers employ various programming languages such as Swift, which is a native language that develops apps on Android on iOS. Sorry, Dart, which is just a language that uses Flutter as a widget library to develop apps for both iOS, Android. Now you can also develop apps for the web, Linux, macOS, and stuff. JavaScript is the core language for React Native and React for web. And we look at Kotlin, which is just advanced Java, and we look at C Sharp, which you can use a lot of things with, depending on the platform. Exactly. So that was mobile development, and there's this other thing called mobile web development. So basically, mobile web development is just using the basic web technology, for example, HTML5, CSS3, and JavaScript, which is just the commonly used languages to develop websites. And you can use those languages to optimize, for example, let's say at work, given a project to optimize a web app to be operational on the phone. As you can see right now, Twitter is using not the ordinary app that we are used to, but they're using this other app that was developed using those three aspects there: HTML5, CSS3, and JavaScript. Instead of using an app that was developed using the native so it has a downfall in performance, but basically at 100 MB, you can download the app at 20 MBs or something. So that is downfall in an advantage as well, as you don't really need to learn something new for you to develop a mobile app. You just have to come in as a web developer and get adapted to the screens of the mobile phones and make it responsive so that it can work on the mobile. Just bringing the website to the mobile. So moving on, we're talking about the mobile engineering process, which is basically just a development process per se. First of all, this ideation or research, which is just basically coming up with ideas, UX, and it's supposed to be UI, sorry, UI or UX design, development, testing, deployment, and post-launch optimization. So On UI UX, you use different tools. Some people use Figma. Some people, hello, hello. Are we still participating?
Yes, we're here.
You're following.
All right, you're following, right? So on the mobile engineering process, because some people mistake a mobile engineer and a software, a full stack engineer, right? Full stack engineers are basically just front end and back end developers of the web. But mobile engineers the same thing, but for mobiles. And this is the process that they use, or the process that I basically use to come up with those things, some mobile apps. I'll give you links at the end of this so that you can see my work if you're interested. So UI UX design, people use Figma, people use Photoshop, and there's this other thing called Penport, which is just a community contributed open source project that basically offers free services for you to design on. That's what I'm using right now. I don't use Figma anymore. I don't use Adobe XD or Photoshop. And for development, you can use any IDE you want. I use VS Code personally, and the recommended IDE to use is the Android Studio, because it's rich in a lot of things. It has a lot of functions that you can look at. And after that, after the development process, you're supposed to test your app and deploy your app on specific platforms. For example, Android Studio, you can deploy your app on Apple App Store or Windows, and post-launch optimization. That's just basically when you get the feedback from people, the people that use the app, the users, they basically come up with a lot of issues that you don't even know exist. So there's something to look out for. So development, there are three types of development. Mobile app development. You can look at cross-platform development. You can look at native development and hybrid. So the cross-platform development is the type of development that offers the same code base on different to operate on, or to compile on different platforms. For example, you can write a single code, a single hello world, but when you compile it on iOS, it will run on iOS. If you compile it on Android, it will run on Android. If you compile it on, let's say, the web, it will run on the web. That's what they basically accomplish. This is good, yeah, but it has its downfalls. As maintaining the code can become expensive in such a way that you have to find someone with the expertise of developing and optimizing both apps for the iOS or for the specific platform that you're using. Let's say Android or any other platform. Yeah. So we have React, Flutter. We also have Ionic in that group, but Ionic is basically just a hybrid development tool. So for native development, these are specifically languages or frameworks that are tailored to a specific platform. For example, we have Swift, which is just basically built to develop apps on the iOS or Apple products, and Java, which is then improved. An improved version of Java was Kotlin, that is now being used to develop apps specifically built for Android devices. And we have Apache Cordova for hybrid. So hybrid development is what I talked earlier in my earlier slides, what I said earlier. It uses basic web development tools, for example, HTML, CSS, and JavaScript, which can then be compiled to work on Android or iOS devices, which is just another form of cross-platform development. but it's hybrid in such a case that it uses web development tools like HTML and stuff, and Ionic as well. It uses all those things, HTML, CSS, and its friends. So you can go crazy with hybrid in such a case that you can use styling, which is basically just easy. You can go crazy with JavaScript in that case, but it's a trade-off in performance. Bundle size is okay. You can produce apps that are small, but performance-wise, it is not okay. So key considerations as a mobile engineer, platform selection. As me, I'm an Android developer. I don't develop apps for iOS. I've never really owned a device that uses iOS. So what gives? I don't develop apps for that. I only started developing apps so that I can help myself accomplish things that I think, let's say, a developer developed an app, and I think I can do better, and I just develop the same app but better than his and use it on my phone. I don't sell those things to just use them on my phone. If it's an application that is supposed to generate revenue, that's just an idea that you have to come up with on your own, or else you'll be sued. So device fragmentation. This is another case concerning compatibility and consistent in user experience. As a mobile engineer, must address this diverse range of devices, screen sizes, and operating systems by utilizing development tools such as native tools like Swift and stuff, like Cordova, or you can just use Flutter to tackle all those things. And performance-wise, there's this other consideration when picking those development tactics or development languages or frameworks, right? For example, performance optimization. If you pick to develop a hybrid app, you have a trade-off that you have to focus your work much on the performance, making your app perform better, which means reducing the number of like API calls, or you can look at the memory usage, the battery consumption, and network connectivity to create efficient applications. Because if your app is not performing well, at the end of the day, you will lose users and people won't use that app. That's why if you look at frameworks like Next.js, you look at frameworks like Next or Vue.js, they're all just frameworks trying to give you a better development process and to give you speed when developing those things, and also for the user experience, right? So you can pick something that has a better performance, but it is very hard for you to develop an app. The user experience is basically crap, and you can't develop an app that the users can use. So what's the point in using those things? So you have to be specific when choosing your development tool. So in conclusion, the mobile engineering process involves several crucial steps from ideation to post-launch optimization. By embracing a meticulous approach to design, development, testing, deployment, and continuous improvement, mobile engineers can create successful applications. So that was all. Any questions?
Okay, that was a very nice presentation, Steve. But I'm just curious,